All right, we're going to talk about 3.3 function notation. And first thing to note about function notation is whenever you see y equals, that can also be written as f of x equals. So when we think of y and we think of f of x, those are interchangeable. Okay, and so function notation allows us to put values in easily for x in an input setting and then quickly see an output. You'll also use it later on in advanced math when you're using different equations and you represent different equations as different functions, and it helps you to substitute a lot easier and to write the math out a lot easier. But anyway, for here, if we have f of x equals 4x plus 1, and we want to say, well, I want to put negative 2 in for x, that means I'm going to write it as f of negative 2. So when I say f of negative 2, really that's 4 times wherever you see that x, you're putting a negative 2. 4 times negative 2 plus 1. Now, this does not mean f times negative 2. This is just a name. So really this is saying when I plug or substitute negative 2 in for x, I get 4x minus 2 plus 1. So you could think of it as when I substitute negative 2 in for x. That's what that is saying. Okay, and then we show our output. Our output would be 4 times negative 2 plus 1, or negative 8 plus 1, or negative 7. So that means you have an input of negative 2 and an output of negative 7. And if I show that in like a table format, in fact, I'm going to do a table format over here to show that, well, when x is negative 2, f of x, or y if you want to think of it that way, is negative 7. So my input of negative 2 gives me an output of negative 7. Now let's go ahead and switch colors and we'll try f of negative 1 here. Okay, and so really that means when I do f of negative 1, I'm now just saying 4 times negative 1 plus 1. And once again, this left side, nothing happens, but 4 times negative 1 is negative 4, and plus 1 is negative 3. So f of negative 1 equals negative 3. That means when I put in negative 1, I get out negative 3. All right, and then we can go ahead and try another one here, f of 0. Okay, so f of 0 is equal to 4 times 0 plus 1. And that's going to be 0 plus 1, or 1. So f of 0 is equal to 1, so we put 0 in, we get 1 out. All right, and now we try a different one here. Okay, let's go ahead and separate this. If we have f of 1, f of 1 equals 4 times 1 plus 1. Notice the only thing that's changing each time is x. We are substituting something in for x. So that gives me 4 plus 1, or 5. So f of 1 is 5. That means when I have an input of 1, I have an output of 5. And my last one, f of 2. And let's use a different color to kind of keep that. Oops. Whoa. Sorry about that. We'll use a different color. And go. So we have f of 2 is equal to 4 times 2 plus 1, or 8 plus 1, which is 9. So f of 2 equals 9. So we have 2, 9. Now you'll notice we're going up by 4 every time on the y-axis, or the f of x axis. Okay, it's increasing by 4, which I don't know, you can actually see that 4 there, so plus 4. And that's happening all the way down here. And we're increasing by 1 up here. And if you remember back to previous functions or previous lessons, that means it's linear. And if you think back also to y equals mx plus b, that that's kind of what we have here. But we're able to graph it now. We have coordinates. We have the ordered pair -2, -7. So -2, -7. It's right there. I'm not going to write the points by each of them, but -1, -3. 0, 1. Okay, oops. 1, 5. And 2, 9. Okay, and so each of those points, or each of those coordinates correspond to a point. Draw a line through them, and there we've got our equation. And it's graphed. Our function is graphed. This is the function f. We usually label that with the f there, and there we've got it. That's kind of what function notation allows us to do. Another way to make the table, if you wanted, and I'll just show it up here really quick, is I kind of like these H tables where you say x, you say the rule is 4x plus 1, and then the output, f of x. So input, output, and the rule. So if we said the input of -2, you'd have 4 times -2 plus 1 would give you the output of -7. And then it's a nice way to just kind of keep track. Input of -1, 4 times -1 plus 1, that gives you the output of -3. And so the same stuff we did down here, but just in a different table format. So it's another way of making a table on it. All right. Next, find the value of x so that the function has a given value. Now, this time, rather than, notice over here we had f of -2. Rather than having like m of -8 or m of 18, we're saying m of x equals 18. That means we actually replace m of x with 18. This replaces or substitutes m for m of x, that whole thing. So this becomes 18. We always substitute inside parentheses, is equal to -2x plus 4. So this is saying, what is our input when our output is 18? And so really what you're doing is you subtract 4 from both sides, you solve the equation from here. Get -2x is equal to 14, divide by -2, and you get 1x is equal to -7. So really that means that m of 7, or m of -7 actually equals 18. When I have an input of -7, I get the output of 18. That's what I was wanting. I was wanting to find out what x would be. Okay? And so if you want to put that in ordered pair format, you could. -7, 18, that's what that is. And the reality is all they're asking you to do is find x. So technically, I guess you could have just stopped right there. But anyway, this next one, p of x is 15. So we're going to substitute 15 in for p of x. It replaces. I like to show my substitution like that. 3/2 x minus 3. And then I go ahead and add 3 to both sides. So I get 3/2 x is equal to 18. And then to get rid of a fraction, it's good to multiply by the reciprocal. So I'm going to switch up colors here. So I'm going to multiply this side by the reciprocal. That's where we flip the fraction, so by 2/3. And by doing that, when I multiply both of these by 2/3, that allows me to cancel here, cross cancel. So I'm left with 1x. And then you can either, when you're multiplying by a fraction, it's 2 operations at once. You're multiplying and then dividing, or you're dividing and then multiplying. So 2 times 18 divided by 3, or 18 divided by 3, this times 2. I kind of like the division. 18 divided by 3 is 6, times 2 is 12. There we've got it. So really this says p of 12 is equal to 15. Okay, order the ordered pair 12, 15. When you have an input of 12, you get that output of 15. And so that's what this is saying. All right, notice that this and this, once you know x, that's what would have gone right there. All right. Well, we now have kind of a story problem here. Let n of h be the number of cars at an intersection near a school h hours after 5 a.m. explain the meaning of N of 4. So H represents hours after 5 a.m. N represents number of cars. Okay, that's our N. So really this is saying the number of cars, N, at, well, 5 a.m. would be 5 a.m. would be N of 0. That would be 5 a.m. That means at 0 hours past 5 a.m. or at 5 a.m. you would have, that would be N of 0. Okay, so let's write that so it's legible. That means N of 4 is you add 4 hours to 5 a.m. So 6 a.m., 7 a.m., 8 a.m., 9 a.m. So this would be N of 4 represents 9 a.m. So this would say the number of cars at 9 a.m. And explain the meaning of this statement. Well, N of 2 would mean, well, 2 hours past 5 a.m. So that would be 7 a.m. So the number of cars at 7 a.m. is greater than so that's this piece, is greater than there. This would be this piece. And then you'd have this chunk right here. That would be the number of cars at, well, 7 hours past 5 a.m. is 12 noon. So at noon. Okay, so the number of cars, and so if we kind of look at this, I've kind of broken it up into different pieces here. Okay. So this would read the number of cars at 7 a.m. is greater than the number of cars at noon. All right. There you got it. All right, well, that's about it. Good lucky.